Example 30. Two towns are located at point A and point B, and a nearby road R is a straight line with equation minus x plus y equals 4. A new taxi firm wants to find a location for a taxi station on the path R so that the combined distance from the taxi station to the two towns A and B is shortest. So this along here, this is path R or road R here, got B and A. They want to find a point on this line where this distance plus this distance is the shortest. A, draw a perpendicular from B to line R. Okay, we were given this, so we put into y equal mx plus b, and though m is equal to 1, the gradient is 1, the y-intercept is 4. Y-intercept is 4, it's got a gradient of 1, which is 5 over 5, so we've drawn the line to there. And the thing was draw a perpendicular from B to line R. That's the perpendicular from B to line R. It's a right angle. B, mark the intersection point C of road R and the perpendicular through B. Okay, so we've written C in here, and that's the coordinate points of C. And the way we calculate that is if we know this line's slope, which we know is 1, then this red line here, BC, must be minus 1 because m1 times m2 equals minus 1. Okay, so we know the slope and we know one point, 1424, so we can find the other point. Okay, that's all written here. So we use y minus y1 equals m times x minus x1. And we get that the BC line is minus x plus 38. So there's a slope of minus 1. And if you continue that line all the way up, it would cut the y-axis at 38. Now, how do we find C? Well, it's the intersection of this line and that line. Now, at that point, the x and y coordinates are the same. So this y equals x plus 4. That y equals this y. So we can say that x plus 4 equals minus x plus 38. We solve for x and we get 17. And then we put 17 into either equation and we choose the easier one, which is this. So we put 17 into there and we get that y is equal to 21. So the point is 1721, and that actually is what it is on here, 1721. Part C, find E on BC such that BC equals CE. Okay, so this is being extended now to the other side because they're saying there's point E on this line such that BC equals CE. Okay, so we find that point is there. Now, how do we know where that point is? We've got to find it, the coordinates of that point. Okay, we know that point C from point B is shifted across by 3. So it's a horizontal shift to the right by 3 because it goes from 14 to 17. And it's a vertical shift down from 24 to 21, so also 3. So if C is 3 down and 3 across, then E would be 3 down and 3 across. Okay, and I've written that over here. So point E will be shifted similarly with respect to point C because BC equals CE, BC equals CE, and the point would become this one here, which would be shifted to the right another 3, so that'll be 20, and that's shifted down from 21 by 3 would be 18. So the point is 20 and 18, and that's what it actually is there too. Look. D, state the relationship between the lines FC and BE. So we're looking at the relationship between FC and BE, where we can see that FC is perpendicular to BE, and not just perpendicular, but it's a bisector, which means that it cuts right in the middle between B and E at the midpoint. And this is from the textbook here. FC is the perpendicular bisector of BE since FC is perpendicular BE and BC equals CE. E, show that AF plus BF equals AF plus FE. Well, that's AF and that's AF. So for that to be true, BF must equal FE. Now we know that BC equals CE. So BC equals CE. We know that. And FC is the perpendicular bisector to BE. We know that that line there is a perpendicular bisector, so we know that they're equal on either side, right? Same thing. Therefore, this triangle here is congruent with this triangle because they share this side, and both of these sides of each triangle are the same. And therefore BF equals FE. We know then that BF equals FE. We know they're equal. And that's what we're asked. BF must equal FE because these are congruent triangles. Okay, and that's the answer from the book there. F, from the triangle AFE, so this triangle, explain why AE is less than AF plus FE. Okay, they're saying explain why this distance here is less than that plus that. Well, obviously the shortest distance between 2 points is directly to the point from here to here. It's a straight line, so that must be shorter than this plus this. Because as this, for example, if this triangle was out to here, this would be quite a long distance to go from A to E. The shortest distance is directly there, so that's why AE is less than AF plus FE, and that's the answer from the book. Next one, they told us that AE intersects road R at point D, so AE intersects at point D. Show that D is the point on the road such that the combined distance from it to the two towns A and B is shortest. So it's at that point that if you add up the distance to there and you add the distance, this distance as well, then this distance plus that distance is the shortest distance when you combine that distance and that distance. So for example, if D was here, you would add that distance plus that distance. But the shortest one will be that plus that if D is positioned here. Now they're asking us to show that. Okay, so I've written here, show AD plus BD is the shortest combined distance from each town to line R. Okay, that's just repeating what they said. So AD plus BD is the shortest distance to each town, from each town to line R. Now we know that these two are the same, BC equals CE. So this distance here, that's a perpendicular bisector, so from here to here is the same as from there to there. It's just a reflection along this line. So what we are finding is this line to here and that. We're going to find that distance there, which would be the total distance of this plus that, is equivalent to this plus that. All right, now the answer in the book says AE and line R intersect at point D. Since AE is shorter than AF plus FE, we were just, that was the previous one, right? AE is shorter than AF plus FE. For any F, AE equals AD plus DB. So AE equals AD plus DE, DB. DB and DE are the same. AD plus DB will be the shortest combined distance and D the location for the taxi station. So what they're saying is because that distance is the same as that distance, that would obviously be the point, which is going to be the shortest. Because this distance from there to there is the shortest distance between these two, so that would mean it's also the shortest distance that way. Yeah, kind of makes sense, huh? And let's look at H. Find the coordinates of D. Well, if we want to find the coordinates of D, we know the equation of this green line here. That's y equals x plus 4. So what we need to do is to find the equation of this line and then find where they intersect. Well, we've got 2 points on this line, so we can find the slope, or the gradient. The gradient is going to be y2 minus y1 on x2 minus x1, and that came out to be 2 on minus 18, which is minus 1 on 9. So this slope, we expect it to be minus, and it's not a very steep slope. So that's 1 on 9, so it's minus 1 on 9. Now that we have the gradient or the slope, and we can use either point in our point slope formula, which is this one here, y minus y1 equals m times x minus x1. I've chosen this point here, A, that point there, and we resolve it up to y equals minus 1 on 9x plus 182 on 9. Okay, so that's the equation of this line. We know the equation of this line here. So we know that at that point, both equations, x and y, is the same. okay, for both the line equations. X and y are the same, so what we're going to do is equate the y's. We're going to put x plus 4 on one side, and we're going to put minus 1 on 9x plus 182 on 9 on the other side, because what we're saying here is that this y equals that y. We resolve it down for x, and we find out that x is 14.6, and then we put the 14.6 in one of the equations, either the equation of this line, which is that, looks a little pretty complicated, or we can put in the equation of this line, because we're looking for the point on both lines. We'll use this one. So it's 14.6 plus 4, which is 18.6, and that was what the answer in the book, where they said from the graph.